Today's do now is very similar to one of the questions we have on our review sheet, so it's a nice little lead-in. The following equations, y equals r plus 2 times x plus 6 and y equals 9rx are parallel. Find the value of r. And it looks really strange with those extra variables in there, but I always want to keep in mind that slope-intercept form of the line. So when we're talking about finding the value of r, I want to identify where r is. And here I can see in both equations, it's what's being multiplied to the x, to the variable, which is really taking the place of our slope. So that must mean that both of these I circled in green are representing the slopes of the line. We just have an extra variable r in there. We're given a second clue that the lines are parallel, and we know parallel lines have the same slope, which would mean that those slopes are equal. So what we can do is we can take each of those slopes and set them equal to each other since the lines are parallel. Now we just solve for r. So we get 2 is equal to 8r, divide both sides by 8, and we wind up with 1/4 equal to r. And there you have it. For today's lesson, I want to go over a few questions we have from the review sheet. So they're just a little out of order. So let's just go to number 5, state whether each equation is linear or nonlinear. We know linear means straight line, nonlinear is not going to be a straight line. One of the things we want to remember from our linear versus nonlinear equations is that when we have a linear equation, all variables have an exponent of 1, okay? So on A, y equals 7x squared, I see that exponent of 2, I automatically know it's nonlinear. Y equals 5, linear, right? It has that little invisible exponent of 1. Same with C, 2x plus 3y equals 10, linear. Now the tricky part is here with D. Y equals 7 over x. I can see an exponent of 1 here with the y and an exponent of 1 here with the x. But what we need to do is think about another way this could be written. If the x were not in the denominator but were instead in the numerator with our exponent rules, it would have an exponent of -1, not +1. So this equation is actually non-linear. And if we were to graph it on the coordinate plane, it would actually look something like that, which would have a curve there. Okay. On number 6, we're doing a little bit of graphing. X equals -2. I want to first realize that that's a vertical line. Okay. Our vertical line equations are always x equals then a number. They have those nice vertical lines with an undefined slope. X equals -2. We go to -2 on the x-axis and then graph our vertical line. And label, of course. Okay. Y equals 3. I want to recognize that this is a horizontal line, has a slope of 0. Y equals a number equation, horizontal line. So we go to 3 on the y-axis because it's y equals 3. And create our horizontal line, arrows on the end, and label. C, the equation y equals x, is what we call the parent graph. Something we want to realize with this equation, if we fill in what's invisible, we can see a slope of 1, right? That coefficient is 1, and there's nothing here being added or subtracted, which means it's 0. So from this, we can identify a y-intercept of 0, meaning a starting point at the origin, and a slope of 1, or 1 over 1, which tells us to go up 1 to the right 1 throughout the coordinate plane, or down 1 to the left 1. Y equals x. Last question I wanted to go over was number 9. converting each of the equations below into standard form. So we want to refresh our memories. Standard form is ax plus by equals c. So really we're getting the constant c alone. We want to remember that a and b and c must be integers. And that a, the leading coefficient, has to be positive to be in that proper standard form. So we're going to try and get these equations into proper standard form. So let's start with y equals negative 4/3 x minus 6. First step, we're going to add 4/3 x to both sides. So that'll make it 4/3 x plus y equals negative 6. Now that's not in proper standard form. Can't have fraction. No fractions. That's the issue. We can't have that fraction there. So to eliminate that fraction, what we do is we take the entire equation and multiply it by the denominator of that fraction. So we multiply everything by 3. So essentially we're distributing it to each term. When we do that, 3 times 4/3 x, the 3's cancel and we're left with 4x. 3 times y, 3y, 3 times negative 6, negative 18. And there we go. Okay. Let's try it again for b. Negative 3x plus y minus 5 equals 15. Let's add 5 to both sides. Negative 3x plus y equals 20. That one looks a little bit nicer. The issue here is that negative. We have to change it to a positive. To get rid of that negative, we're going to take the entire expression and, entire equation and multiply every term by -1. So we're going to change the signs. Okay, so that makes this positive 3x minus y equals negative 20. And now we are in proper standard form. A little reminder of some of the little details you want to be aware of as you're going and taking tomorrow's test and filling out the review sheet, because practice what you want to do on the test. Make sure we're putting arrows on both ends of the line we're graphing, that you are labeling all lines and inequalities that you've graphed. You're labeling the solution to the system, whether it be a system of equations or inequalities, and that you're extending lines and shading through the coordinate plane. As a reminder, the answer key to the review sheet is posted on Google Classroom, as well as videos that you can scan through to get to the problems you're looking for. So that review sheet is due tonight at 9 o'clock, and then tomorrow we have our linear equations and inequalities test. Today's math jokes for Matthew folks. Did you hear about the mathematician who was afraid of negative numbers? He would stop at nothing to avoid them. Get it? Stop at nothing? Negative numbers? Have a great day.